All right, guys, welcome back. We are going to dive into lesson 5, which is continuing our talks with algebraic expressions and writing rules for them, or the directions for them, and solving them. So join me here on page 23 and we'll get going. So here we're talking about the language and logic of expressions. So you'll see a lot of repeated stuff that we've been doing this whole time. So here we're going to complete all the cells in the table. So here we're thinking of a number, and Carla here has a number at the end that we'll kind of work our way backwards with. Get the whole thing here. And remember, the way this is written tells us the whole story of what's going on through here. Okay, so we first had n, then we had 2n, then we had 2n minus 8, then we took that times the 5 on the outside. Then we took that whole thing divided by 10. And then we added the 16 to it. Okay, so now we'll do our instructions here. So we had an n, then we had 2n. So multiply by 2. Then we subtracted 8. Then we multiply by 5. Then we divided by 10. And then we add 16. So if I go the other direction, I have the end result. In fact, this thing equals 19. I do these steps backwards, or I do the inverse of it. So instead of adding 16, I'm going to subtract 16. So 19 minus 16 is 3. I'm not going to divide, I'm going to multiply by 10. So 3 times 10 is 30. I'm not going to multiply by 5. I'm going to divide by 5. So 30 divided by 5 is 6. I'm not going to subtract 8. I'm actually going to add 8. So I get 14. Instead of multiplying by 2, I'm going to divide by 2 and I get 7. Okay, so her n is 7. So if I were to plug in down here, I would get 7 out. So algebraic habits of mind, seeking and using structure. Algebra helps us express information like the steps in a number trick compactly, but sometimes that compactness can make things look complicated. You can think of each part of an expression as one step in a trick. Find the last step that was done and undo that first. Then undo the next to last, and so on. Unravel the problem one step at a time from outside in. So finally, finding Carla's starting number is like showing this equation. So this equation we just did. And if I just show you this thing, it does look very confusing and complicated and very hard. Okay. But if we actually think about the structure and what makes the problem, it can be very easy. These expressions have been taken from different number tricks. In each problem, write only the instruction that was performed last. You can refer to the result of an earlier instructions by just saying the result. Okay. Divide the result, which means the previous step, by 11. This divide by 11 is the last thing that they did. Okay. Here, the last thing they do is multiply by 9. So we're going to multiply the result by 9. Divide the result by, or divide by the result, are two different things. Okay, kind of like the subtract a number and subtract from a number the other day. Again, try it with a few numbers. For 10 divided by x plus 1, you might think, suppose x is 4, and am I thinking of my 4 adding 1 and then dividing by 10, or am I thinking of my 4 adding 1 and then dividing 10 by that result? Okay, and in that case, you're actually dividing the result. You're taking 10 divided by the result. Okay. All right, so here's some more here. So you have 8 minus 3h. So this is the result, but you're taking the result from 8. Okay, so subtract the result from 8. So this thing is the result, and you're subtracting it from 8. Divide 14 by the result. Again, this is the result, so you're taking 14 divided by the result. Okay, here's a tough one. They've got a lot of things in here. So the last step that you're actually going to do is subtract 6. All of this is the result. Okay, so you're going to subtract 6 from the result. Okay, here's the result. This is what you're doing last. So we're going to add 4 to the result. All right, here we'd have to start here and then multiply by 5 and then do this. So we're going to add so this is the result. So we're actually going to add the result to 3. 2, 3, which is a little bit different than up here. Okay, it was in a different order. Okay, and then this one, this whole thing is the result because it was in parentheses. So we're going to multiply the result by 2. All right, page 24 here. Match each expression with a phrase or set of instructions. Okay, so we're going to take these, match it with these. So this looks like the result, subtract the result from 5, or x less than 5. So this is 5 left. Let's start over here. 5 less than x. So that's taking x minus 5. So that would be A in this case. Or sorry, that goes with 11 here. This is 5 is less than x. Okay, so we got some other symbols here. So 5 is less than x. So this one goes here. B. X is less than 5. So this is the less than symbol. So that goes there. X less than 5. Okay, so notice the wordage. We had is there, which means result. Okay, and then these represented that. So x less than 5, which means subtraction. So that's D. And then 5 more than x, which means add. So we're there. So in math, a lot of times you have to really focus on the words that they use in the order that they're using them in. Subtract 7 from B and then square the result. So subtract 7 from B and then square that result. So this is A. Square B, then subtract 7. Okay, looking through here, square B, then subtract 7. Square B, then subtract that the result from 7. So that is just rearranging the order there. Okay, so we're going to square b, and then that result we're going to take away from 7. Subtract b from 7, then square the result. Okay, and that required us to put some parentheses in there. All right, number 19 through 22 at least. Write an algebraic expression to match the sentence. 4 less than twice some number. Okay, so twice some number would be 2n. And if you want 4 less than that, you're going to subtract 4 from it. 4 minus twice some number. Okay, so 4 minus twice some number. So you're going to take the twice that number from 4. Subtract 3 from half of some number. So you got some number and you want half of it. And then you want to subtract 3 from that result. 1 less than the square of some number. Okay, so you got the square of some number, n squared, and you want 1 less than that. Okay. Algebraic habit of mind, communicating with precision. How you express mathematical ideas affects how you will think about them and how well others understand you. Telling these phrases apart, x less than 5, 5 less than x, 5 is less than x, and x is less than 5 requires precision attention to meaning. Okay, it's all wordplay in here. Okay, notice we're just rearranging the letters and the numbers, and we're putting the word is in there. Okay, those are all slightly different things. Okay. Eva thought of a number, added 4, multiplied by 3, subtracted 7, and got 32 as her final result. What number did she think of? How did you figure it out? Well, if I start at 32 and I want to go backwards, I just do the inverses of everything. So if I start at 32, okay, and instead of subtracting like she did, I'm going to add 7. And that result would be 39. Okay, so I did that. And then instead of multiplying by 3, I'm going to take that divided by 3. 39 divided by 3 is 13. Instead of adding 4, I'm going to subtract 4 from that and get 9. And then that's all that she did. So 9 must have been her starting number. 24, Jacob thought of a number, added 5, multiplied by 2, and subtracted 8. Write an expression for Jacob's trick that describes the computation Jacob performed. Okay, well, he thought of a number, x, then he added 5 to that. Then he took that whole thing, which means we put parentheses around it, multiplied by 2, and then took that whole thing and subtracted 8. So you could put that in parentheses if you wanted, but you don't have to. Jacob got 24 as his final result. Lena used her simplified expression for his trick, 2n plus 2, to create this equation. 2n plus 2 equals 24. Use it to find the number Jacob thought of. Okay, so 2n plus 2 equals 24. Now, if I solve this equation like some of the basic algebra I know you guys have done, we're going to do the opposite of add 2, which is subtract 2. So these go away. I get 2n equals 22, and then divide by 2. So n equals 11. So Jacob should have started with the number 11. And you can check it. Okay, 11. 11 plus 5 is 16. 16 times 2 is 32. 32 minus 8 is 24, which is what Jacob got. What's the difference between equations and expressions? Equations have an equal sign. 2x plus 3 equals x plus 4, and x equals 1 are both equations. Expressions do not have an equal sign. 2x, 2x plus 3, b minus 7 squared, etc. are all expressions. So an equation is actually two equivalent expressions. So this side is an expression and this side is an expression, and we're saying that they are equal to each other. Okay, got a couple more here before we finish up. In these puzzles, both the pentagon and the clover are integers less than 10 and not negative. It is possible for the pentagon and the clover to be equal. Okay, so if 2 pentagon equals a clover, what are the numbers that the pentagon and the clover could be? Okay, we'll start with the smallest one. Okay, they're between 10 and they're an integer, not negative. So that's 0 through 10, or well, actually 9 if it's less than 10. So if the pentagon is 0, 2 times 0 is 0. If the pentagon is 1, 2 times 1 is 2. If the pentagon is 2, then 2 times 2 is 4. If the pentagon is 3, 2 times 3. Oh, I'm sorry. I messed up. It's not 2 times pentagon. It's pentagon times pentagon. That's pentagon squared. Okay, so that's still 0. This is still, or this is 1. 2 squared is still 4. 3 squared is 9. That's my fault. I did that the other day too. Okay. If both 26, if both these equations are true, what could a pentagon and a clover be? Okay, so from up here, we had this equation right here. Okay, and we said that a pentagon could be 0, 1, 2, or 3. Now, let's see if this works out as well. Okay, and using these numbers from a clover. So if I put 0 in, 0 plus 0 is still 0. So that one worked. So it could be 0 or 0. If I put 1 in, 1 plus 1, did that give you a 1? No, it gives you a 2. So that doesn't work. 2 plus 2 is 4. So that one worked. And then if we do 3 plus 3 is 6, which wasn't 9. So only these numbers would work out here. If the pentagon does not equal a clover, then what could a pentagon and a clover be based on the equations in 26? So now they're saying that these two cannot be the same thing, which here in 0, 0, they were the same. So 2 and 4 are your only options there. Okay, what this is we're solving a system of multiple equations, and we took 3 steps there to do it, which is fine. It doesn't matter how many steps it takes as long as you understand the process. All right, we're going to stop there. The next lesson we'll come back and finish this lesson 5 up so that you can take the quiz. You can go ahead and probably start your additional practice on page 27, at least get halfway done with that so you're ready for the quiz. If you have any questions, feel free to reach out and let me know. I'll see you in the next one.